In the face of eternity, the future whispers its secrets in the language of the stars. In our night sky, each shimmering star tells a tale. The universe is a grand storybook, filling its pages with wonders beyond our wildest dreams. We all heard the story of how it began. But what, if anything, awaits it at the end? Home. This pale blue dot we call Earth has witnessed the rise and fall of empires, the dawn of technology, and the ceaseless march of evolution. From the first flicker of life in primordial seas to the bustling cities of today, our planet has been a cradle of endless possibilities. But Earth's story is just one chapter in the cosmic tale. As we journey through time, we'll explore the future of our home, the fate of our solar system, and the destiny of the universe itself. But even cradles eventually break. Billions of years may seem like forever, but in cosmic terms, it's merely a breath. Our star that we so comfortably orbit is not static. It too is on a journey towards its own end. As hydrogen fuses in its core, slowly but surely our sun brightens. Not in a sudden blaze, but with a relentless, ever-creeping intensity. Oceans that once teemed with life will begin to simmer, then boil. The atmosphere that once offered protection will swell and thin, offering no refuge from the increasingly harsh rays. Our vibrant blue marble will transform. Deserts will stretch to engulf continents. The last vestiges of water will vanish into space. Our home, once a haven, will become a scorched and desolate rock, circling a star that has grown too old, too large, too bright. And yet, the story doesn't end there. The sun's demise is but a local event in the grand story of the universe. Our solar system, this small family of planets, is itself part of a much larger city of stars, the Milky Way. What fate awaits this swirling island universe? Even as our star ages and Earth's story as a habitable world draws to a close, the Milky Way itself is not static. It too is destined for change. Our island universe is not alone, and one neighbor in particular is on a collision course with us, the Andromeda galaxy. In billions of years, gravity will draw these two galaxies together in a slow, inevitable dance. Andromeda, larger than our own Milky Way, is approaching us at 250,000 kilometers per second. It seems impossibly fast, yet on cosmic timescales, it's an incredibly slow embrace. This is not a head-on crash, but a graceful merger, a slow intertwining of two behemoths. Over billions of years, the merger will progress. The two galaxies will lose their individual identities, blending together to form a new, larger galaxy, nicknamed Milkomeda or Milkdromeda. The familiar spiral structure will likely be disrupted, evolving into a giant elliptical or irregular galaxy. Our solar system, if it still exists, will find itself in a vastly changed galactic environment, orbiting within this newly formed cosmic entity. The merger of the Milky Way and Andromeda is a colossal event, a reshaping of our galactic neighborhood. Yet, even this galactic transformation is not the end. Milkomeda, like all galaxies, will still be subject to the larger forces shaping the universe. The expansion of space, the fate of stars, the ultimate destiny of the cosmos. These grand narratives continue, even beyond the merging of galaxies. Our journey towards understanding the end of everything must continue outward, to the very edges of the observable universe and beyond. But the vibrant starburst ignited by Milkomeda's merger was not to last. Like a bonfire consuming its fuel, the galaxy is now facing a slow but inevitable decline in star birth. The vast clouds of gas and dust, the raw materials for new stars, are slowly being depleted. For billions of years, these clouds have been compressed and sculpted by gravity, giving rise to generations of stars. But with each new star born, a little less material remains for the next. The galaxy is slowly using up its stellar inheritance. And it's the big stars, the luminous giants that blaze so brightly and die so quickly that are becoming increasingly rare. These stellar behemoths require vast amounts of gas to form, gas that is now in shorter and shorter supply. Milkomeda is entering an era where the birth of truly massive stars is becoming a distant memory. The age of grand, brilliant star formation is waning. The universe and galaxies like Milkomeda are transitioning to a quieter, more subdued stellar existence. But even as the era of massive stars fades, a new chapter is about to begin, an era dominated by the universe's most enduring stars, the Red Dwarfs. The era of red dwarfs has dawned. For trillions of years, these small, unassuming stars will become the primary light source in galaxies across the universe. Their faint, reddish glow will illuminate planetary systems for eons, a testament to their incredible longevity. But even these stellar misers cannot burn forever. Imagine worlds bathed in a perpetual twilight, lit by the soft crimson light of a red dwarf sun. These stars, far smaller and cooler than our own sun, burn their fuel with incredible frugality. A single red dwarf can shine for trillions of years, outlasting all other stars by an almost unimaginable margin. For an epoch that dwarfs the entire history of the universe to date, the cosmos will be illuminated by their patient, enduring light. This is the age of cosmic patience. Civilizations, should they arise around these red dwarf suns, would witness a sky that changes imperceptibly over countless millennia. Evolution would unfold on timescales that dwarf even geological epochs. Life, if it persists, would adapt to the faint, long-lasting warmth of these diminutive stars, in a universe slowly fading towards its twilight years. But even this era of red dwarf dominance is not eternal. The universe continues its relentless march towards entropy. And even the most frugal stars, after trillions upon trillions of years, will eventually exhaust their fuel. The faint reddish glow that has defined this epoch will in time also begin to fade, as the universe prepares for its next, even darker chapter. But even embers cool. Even the longest flames must eventually yield to the relentless passage of time. The era of red dwarfs, that vast epoch of faint enduring light, is drawing to a close. After trillions upon trillions of years, these stellar misers are finally exhausting their fuel. Slowly, inexorably, the red dwarfs begin to die. Their reddish glow weakens, flickers, and then fades into the darkness. One by one, then in ever-increasing numbers, these once patient stars relinquish their light, joining the growing ranks of stellar corpses. The age of starlight, in any recognizable form, is ending in galaxies across the cosmos. In their wake, they leave behind their remnants, white dwarfs, neutron stars, and black holes. White dwarfs, the cooling cores of former stars, are scattered like faint embers throughout the ever-darkening void. Neutron stars, exotic and incredibly dense, spin silently, some still emitting faint pulses of radiation. And black holes, the ultimate gravitational sinks, lurk unseen, their presence betrayed only by their absence of light and gravitational influence. Galaxies are transforming into vast stellar graveyards. The vibrant islands of light they once were are now fading memories, replaced by dim, ghostly structures populated by the remnants of stars. The universe is growing darker, colder, and quieter. The whispers of the future are becoming fainter still, carried only on the residual heat of cooling stellar corpses, and the silent gravitational presence of black holes in the deepening cosmic night. The stellar graveyards deepen their shadows. The faint embers of white dwarfs, the last visible remnants of stars, are now themselves beginning their final agonizingly slow fade. For trillions upon trillions of years, these compact stellar cores have been radiating their residual heat into the vast emptiness of space. Imagine a universe where the brightest objects are no more luminous than dying embers. White dwarfs, composed of incredibly dense matter, are slowly surrendering their remaining thermal energy, cooling down degree by infinitesimal degree, getting ever closer to absolute zero, but never to actually reach it. Their faint glow, once a testament to stellar fire, is now a whisper of heat in the encroaching cosmic cold. Over unimaginable eons, this cooling continues. The white dwarfs dim and fade, their light becoming redder, then infrared, then eventually vanishing into the blackness. They transform into black dwarfs, theoretical objects, stellar corpses so cold and faint that they are practically invisible, merging seamlessly with the darkness of space itself. The universe is becoming a realm of black dwarfs, silent and unseen, scattered throughout the ghostly remnants of galaxies. The era of visible starlight is definitively over. Darkness reigns supreme, broken only by the occasional fleeting burst of Hawking radiation from a distant black hole, or the even fainter whispers of particles drifting through the void. The cosmos is entering an age of near-absolute blackness, a prelude to its ultimate fate. But even the black dwarfs, these cold and silent stellar remnants, are not the ultimate end of the story. For if we wait long enough, for timescales that dwarf even the age of red dwarfs, another even more fundamental process may unfold. Proton decay. Protons, the very building blocks of matter, the seemingly stable cores of atoms, may not be as eternal as we once believed. Some theories in particle physics suggest that protons themselves are inherently unstable, destined to eventually decay into lighter subatomic particles. This decay is predicted to be incredibly slow, with a half-life far exceeding the current age of the universe. Imagine waiting for 10 to the power of 30 or even 10 to the 40 years, timescales that are so vast that they cannot be fathomed. Over such unimaginable eons, proton by proton, atom by atom, the very fabric of matter begins to unravel. Black dwarfs, neutron stars, even planets, all structures made of protons and neutrons would be vulnerable to this slow, relentless dissolution. If proton decay occurs, the universe will undergo a further simplification, a further emptying out. The stellar remnants, the black dwarfs and neutron stars, will themselves eventually dissolve. The universe will become even more dilute, composed of increasingly fundamental particles and radiation, drifting through an ever-expanding void. The whispers of the future become almost indistinguishable from silence itself, as matter itself begins to fade away. Even as matter itself dissolves, the stage for this cosmic drama continues to expand. Space itself, the very fabric of the universe, is not static. Driven by the relentless push of something so mysterious, so elusive, that we have dubbed it dark energy. Under the influence of this invisible force, the expansion of the universe accelerates, stretching the cosmos to unimaginable extremes. Imagine space itself as an infinite fabric, being pulled and stretched in all directions. Galaxies, galaxy clusters, the largest structures we know, are carried along on this cosmic tide, drifting further and further apart. The distances between them become truly immense, dwarfing even the vastness of galaxies themselves. As space expands, the universe becomes increasingly dilute. Photons of light, the last messengers of energy, are stretched to ever longer wavelengths, losing energy as they traverse the growing distances. The cosmic microwave background radiation, the afterglow of the Big Bang, once a faint warmth permeating the universe, is now redshifted to near nothingness, its temperature approaching absolute zero. The observable universe itself is changing. As expansion accelerates, galaxies beyond our local supercluster are receding from us faster than light. Their light will never reach us. They are disappearing beyond our cosmic horizon, lost to us forever. The universe is not only growing darker and colder, but also increasingly lonely, as each surviving pocket of observers finds itself isolated within an ever-expanding void. But even these cosmic abysses are not truly eternal. Even black holes, the ultimate devourers, are subject to the universe's fundamental laws. In the face of eternity, even nothingness is not quite nothing. A subtle quantum process, known as Hawking radiation, dictates that black holes, incredibly slowly, lose mass and energy. Imagine a black hole, not as a static void, but as a slowly evaporating droplet in the vast emptiness of space. Hawking radiation, a faint quantum whisper at the edge of the event horizon, carries away minuscule amounts of energy, particle by particle. For stellar mass black holes, this process is agonizingly slow, taking far longer than the current age of the universe. But for supermassive black holes, behemoths millions or billions of times the mass of our Sun, the timescales are truly mind-boggling. They will persist for somewhere between 10 to the 67 and 10 to the 100 years. numbers that dwarf all human comprehension. Even these colossal objects are not immune to the relentless erosion of time. Slowly, imperceptibly, over unimaginable eons, black holes will shrink. Their mass will diminish, their gravitational influence will weaken, and their faint Hawking radiation will continue to carry away their essence. Until finally, after an eternity of cosmic time, they too will vanish. The black hole universe will dissolve. The cosmos will be devoid of even these ultimate objects, left only with the faintest whispers of radiation and a vast expanding emptiness. Silence descends. Absolute and eternal. Heat death. The universe in its vastness journeys towards a future beyond imagining, a future of cold, darkness, and ultimate emptiness. Stars will not reignite. Galaxies will not reform. Even time itself, stretched across unimaginable eons, loses all meaning in this final still state. But before that unimaginable future, there is this moment. A moment of vibrant skies, burning stars, swirling galaxies, and the fleeting spark of consciousness that allows us to witness it all. A moment, impossibly brief on cosmic scales, where complexity, beauty, and meaning can and do exist. In the face of eternity, in the shadow of heat death, this moment becomes all the more precious. Our lives, our loves, our fleeting experiences. These are not insignificant dust motes in an uncaring void, but extraordinary sparks of being in a universe that, for a time, allows such sparks to ignite.